My name is Gabriel Monroy. I'm here from OpDemand. I'm the CTO at OpDemand, and we're the creator of the Deis project. I've been working in and around the developer tools and deployment automation space for some time now. Was an early contributor to the Docker project, and now spend a lot of my time focused on platform as a service, and specifically open source platform as a service. So we're the creators of the Deis project, and Deis is an application platform, is the term that I like to use to describe it, otherwise known as a PaaS. And I think the best way to describe what we do and what we provide to the many customers and users who are running this today is private Heroku. For those of you who are not familiar with Heroku, it's one of the leading public services for platform as a service and basically developer deployment automation. So Deis actually is 100% open source, written in Go and Python, and the idea is to provide enterprises with the same type of experience that you get from a platform like Heroku, but with the control that you need, the ability to run it inside your data center, on your own gear, with your own network and security topology, but again, with the same workflow and benefits. So why platform as a service, right? Why is this even interesting? Why is this technology space interesting to enterprises? There's really two things that are business value that come out of the platform. The first is the idea of developer self-service. Now, if you have a team of software engineers, you really want to empower those engineers to do what they do best and do it quickly without being burdened and slowed down by typically operations folk and system administrators who are really concerned about uptime and reliability. So you're constantly in an enterprise trying to balance the ability to move fast with the ability to be safe and make sure that things aren't going down. A platform as a service provides that ability. So you have all these different parts of the workflow, ability to create applications, deploy your own code, configure runtime environments, manage releases and rollbacks, collaborate, as part of a team, because we all know software is written by teams and not by individuals. So developer self-service is key. Now, one of the big things that you get if you actually can achieve this is you can get to a place where you have this nice division of responsibility. And that's the other big thing platform as a service provides, is it essentially the platform is something, a service that the enterprise operations team stands up and provides to the software development function inside of an enterprise. And this allows a nice clean separation of responsibilities and essentially an API between the different teams, so that the operations guys can make sure that the platform's up and the developers can write software at their pace, deploy it, scale it, pull something down, get an alert that something's going wrong live in production, all without having to go to the operations team for that. The operations team is serving essentially the fabric. So our project philosophy has been to release early and release often. We release this incredibly early. We're very, very well integrated with the Docker ecosystem. Not sure how familiar many of you are with Docker, but we were one of the first companies to actually build a business and technology on top of Docker. So that's enough about philosophy. The project's done really well. We are one of the top trending projects on GitHub for Go-based projects. Lots of metrics behind that. We know of about 200 plus deployments of Deis in the wild. These are at companies of all sizes, from your smallest startup to your largest enterprise, spanning verticals: financial, digital media, e-commerce, lots of different verticals. We're doing this with 5 full-time developers. Now, granted, if you're a developer developing software for other developers, you have to be of a certain caliber. So these are pretty high-powered folks. But they're supplemented by 68 open source contributors. Now, these are people that we don't pay. But they have contributed code in one form or another to the Deis project. Some of them contribute regularly and frequently, so much so that I wonder what they actually do for a day job. So how does it work, right? The main important thing to think of is we are built atop a specialized operating system called CoreOS. And CoreOS is similar to Red Hat or Ubuntu Linux or something like that. It's a Linux-based operating system, but it's specifically designed to run new technology called operating system containers, which Docker is probably the most famous of these container technologies. So CoreOS provides the capability to run Docker, and then we sit on top of that and provide essentially the platform workflow that allows businesses to operationalize the technology benefits that containers can provide. Containers are great in theory, but if you don't have a developer workflow and a platform workflow to operationalize that, it's really just theoretical gains in terms of density and all the other things. So this is a sample workflow of, how a developer might deploy an application. I'm going to show you a similar workflow, shortly. Developer pushes a new build into the system. We attach that with existing configuration. We cut a new release. That release is then published to a Docker registry, which we ship and co-locate with the platform. We then talk to a container scheduler. I believe the folks at Mesosphere spoke here at the last meetup. We work very closely with them as one of our scheduling technologies, and we leverage a scheduler to actually distribute those containers across a large-scale distributed system. When they are available, we publish those containers to a router, and then they're exposed to traffic from the public internet or to whatever the consumer of the application may be. So I'm going through a lot here, but this is essentially how the platform works. So walk you through a quick demo. Now, this is, of course, a command line interface. Developer tools are, many of them are command line focused. I'm going to walk you through deploying an example Go application. Now, this application is actually hosted on Docker Hub. So if you see the Deis create, we're essentially creating a space for an application. The Deis pull command is referencing the name of an application that's sitting hosted on the internet at Docker Hub. And this is an application that was published prior to this demo. And with one command, I can actually suck the application in bit for bit from the Docker Hub, and it's automatically deployed onto the platform. With the curl command is a command, basically a web browser, and you can see the web application is printing powered by Deis. Now, you always are going to need to configure your applications. So I can provide here an environment variable called powered by using the config set command, and I can say powered by your existing Docker images. This is really just a placeholder to show you, what, for example, you might be connecting to a database or a message queue or, some other distributed system. And you can see here, this cut a new version, v3, when we change configuration. And now if we look at the website again, we can see that change has been rolled out. We also have the ability to run one-off ephemeral containers against a deploy of this application to, for example, inspect the current process environment, or do things like run a schema migration, or any of the different types of one-off admin tasks you might need. Now, critically, when it comes to scaling this thing, scaling is one command away. Deis scale CMD equals 4. I'd love to talk more about this, but it happened in 9 seconds, so there's not so much I can say about it before we start moving on. But it's able, you're able to scale, to 100, 1,000 containers literally in seconds. And if you think about this compared to other mechanisms for scaling, this is an order of magnitude speed up. Now, you can also see we've aggregated logs for the developers. We have a release ledger with, that has an append-only set of changes that were made to the application. And we can also do things like rollback. So if there's a change and monitoring shows that something's broken, we can all of a sudden just say, and the developer can do this. They don't have to actually ask the operations folk. They can say, let's roll this back. Things are broken. The pager went off or whatever it may be. Roll back, and it actually rolls forward version 4. It's technically how it works, and now we're back to powered by Deis. So that's essentially the demo of sort of the primary workflow. We actually support many different deployment models: Git push with Heroku build packs, Git push with Docker files, and the ability to suck in Docker images, which is what I just showed you. So some of the reasons why you would choose something like Deis, from the business end, speed. This really comes down to the agility of the software team. If your software team is being blocked by the speed at which they can push software out, bug fixes, but also new features, that is going to be problematic. And you're probably already hearing about it. People complaining about how fast they're able to how long does it take for you to take a new feature and put that out into production, right? Measure that amount of time. Typically, in the largest of large enterprises who don't have this type of technology, it can be weeks. weeks, right? Because you have to provision servers to manage capacity, and it can be an arduous process. If you're maybe more automated and you're dealing with configuration management tools and things like that, maybe you're down to days or maybe even hours to provision and deploy new software. We're talking here about seconds. Like I'm talking, I just scaled an application that could have easily been 100 containers in about 10 seconds. So the rate at which you can respond to traffic spikes and things like that is just, it's really unparalleled. Another big important point here is density. Container technology is unique in that a lot of people compare it to virtualization, but it's really quite different. With virtualization, you're able to take a physical machine and you're able to pack a bunch of different virtual machines into that one physical machine. But each time you do that, you're actually including a kernel, device drivers, and all this other stuff that you don't really need in order to get your segmented application. So another way of talking about containerization is process-level virtualization. So it's as if you were running the same virtual machines, but you're running at the process level. So you don't have all the overhead of the kernel. You can get massive density gains on the hardware. In the wild, we've seen, it obviously depends on the workloads, but up to 10x density gains, which are reminiscent of what happened when VMware first started deploying virtualization across the data center. So in my opinion, we're at one of those moments again here with containerization where we're about to see a massive consolidation from applications that can be containerized into a shrinking of the footprint required for those applications inside the enterprise data center. And the last point here is control. There's lots of public PaaSes. Heroku is a great one. Google offers App Engine, another great public PaaS. We were really interested in building something that enterprises could use inside their own data center. And so we are really the only, one of the only or very few games in town when it comes to running your own private platform as a service. So pretty unique. Interesting announcement. We're pretty far along technology-wise. We've been doing this for a while. We first released the first version of Deis very early, August of 2013, but we've continually iterated on it. And we last night announced our first stable release candidate. So we are about just a few weeks away from announcing our first stable release. So right now we're in a feature freeze. We're just focused on bug fixes, documentation, and improvements to automated testing. One thing I'll point out, when you are building software that other software teams rely upon, the burdens on you for automated testing and the quality of the software are much, much higher. The stakes are higher. So we have invested a huge amount of resources in ensuring that our automated test suites prove that the software is in fact, robust. I'll give you an example. We have 68 contributors, who have contributed software to Deis. The process for them to actually get code merged into Deis is incredibly arduous. Our test suite takes over an hour to run for even the smallest change, because we have to make sure that absolutely nothing is broken before we actually merge that code. So, we're doing a fair amount more work there. Post-stable, we're going to be integrating with some alternate schedulers. The folks at Mesosphere are, people that we're working very closely with as a way to achieve sort of Twitter and Airbnb style scale with Deis as the driving platform. And Service Gateway, TCP support, interactive TTYs, lots of other stuff. Interested in your questions? Yes? So it seems so obvious when you explain containerization versus virtualization. Why did it take this long to happen? That's a really great question. So, I think that the technologies behind containers have been around for a while, right? So, containers are really about the idea of Linux kernel namespaces to isolate processes and C groups to provide resource restrictions inside of a single operating system. Those have been around in the kernel for a long time. What Docker did is Docker actually made these things usable. And part of the way that they made them usable is that they added a third leg, process isolation, process resource restrictions, and then an ability to move around file system diffs, basically, essentially changes of file systems. So you can, add, create a Docker image, add a couple of things to it, and then save that off. And then add a couple more things on top and save that off. And when you move those images around, you're only actually transferring the differences between the different file system layers. Now, without that, you have containerization technologies, things like LXC that have been around, but you had to manage the entire entire operating system on disk somewhere. And that was just too burdensome for people to actually use. So I think Docker did a lot of things right, but the biggest one was the copy on write file system and the ability to move layers around to a registry. Yes?
If you're entirely open source, what's your business model? Who's paying for the 5 developers?
Sure, that's a great question. So OpDemand is paying for the 5 developers. We sell support and professional services to companies typically that are putting this into production. And we're selling those contracts today. It's a pretty standard open source business model. We have plans to come up with other revenue streams down the line. But right now, we're really focused on helping companies succeed with this in production and selling them support. Yes.
So on that note, which industries have you seen the greatest uptick so far?
Well, the industries that have that we've seen the greatest uptick are the ones that have the most to gain from this type of technology, right? And so those are typically ones with lots of developers and ones who have lots of applications that they need to deploy. So we do really well in web and mobile development shops. I believe someone here, is an iOS developer. If you do any server-side development, those type of organizations are very quick to jump on board with this. Also, digital media companies, we have social networks, finance companies, really anyone who is interested in doing modern application development. And by modern, I mean service-oriented architecture, microservices, stateless application tier, kind of the avant-garde of what's currently happening in the enterprise today. Other questions? Great. Thank you so much.